A very good afternoon to all of you. I am Dr. Arun, and today I will be presenting the overview of the work which I have done with my team in the NUS. And I want to apologize for the delay which has been caused due to this software. I have not anticipated this. And I was using the Mac, and in the Mac, it was not possible to connect. So we have been trying it since 8:30. And somehow I went to the office and then we have started this one. So thank you for bearing with me. So I hope it's audible. In case it's not audible or you have the question in between, you can ask the question in between, or you can message me later on, or we will have the question answer session later on. Because this talk was supposed to finish by 10:30. We are late, but still I will try that by 11 we should finish it, okay? Or before 11 we should finish it. So as I have mentioned, that this work which I am going to present has been done in the NUS Singapore. So National University of Singapore, this work has been done. And the topic of today's talk is personalized visual comfort and energy efficiency in the office building of the smart city using the IoT. So this work was done when I was a postdoctoral research fellow in the electrical machines and drives laboratory, and that's EMDL lab in the Department of Electrical and Computer Engineering. So this work is a mix of the electrical and computer engineering part. So some of that we should take notice of. And the work has been done between the 2015 to 18. So some part might be you would have heard, because this is a 3-year-old work. Might be some advanced system, but still I believe this system is quite advanced. And for the India, it's quite advanced, and we have a patent for this also. So I was the postdoctoral research fellow there. I have worked on that, as well as some of the team members which were working with me. So some of the master students came and went in between the project, and some BTech students were also involved, but they were involved in very small modules. And this research was funded by the National Research Foundation. National Research Foundation of Singapore is the biggest funding agency for the research funding, and jointly by the Building and Construction Authority, because this project involves the offices building. So if any kind of work you want to do, you need their permission. So Building and Construction Authority was involved along with the National Research Foundation. They have funded us, and they have funded us quite a lot of projects. So today's work, I will talk more about the smart lighting part. We have been also funded for the ACMD part, so that might be taken care of maybe in next talk or something. So as we know that Singapore plans to be the first IoT-enabled smart city in the world, and to achieve this goal, we were funded to produce some novel solutions. So we worked on the smart lighting, smart ACMD, air conditioning, and mechanical ventilation. In this talk, our focus would be to overcome the smart lighting work, and I have left out the smart ACMD work for the other time if we have time. So later on, maybe some other time we can take up that. So that was a bit of intro before we started this talk. Okay, so these are the outline of my talk today. So first I will introduce the motivation and objective behind our work. Then I will explain the framework of the proposed wireless sensor network for smart lighting. Following that, I will explain the component of the smart lighting system, and which contains the app, control modes, design, and server side. Then I will show you the end product which was developed in our lab. So we usually give the live demo in the lab, but because that is not possible now. So I will show you few of the pictures of the real test bed which have been developed in the NUS lab. And now this system has been installed in some parts of the buildings also. Okay. So lab picture I have, building picture I have not included on that. So then I will conclude my presentation with some concluding remarks. So I will give you the references of the paper, which were the direct outcome of this research. So at last, I will show you that. So here you see in this picture, you will see that we are consuming more and more energy every year. And this is the main cause of global warming. And though a few developed countries are consuming way too much of energy than the other developing countries, as we can see in this chart. So if this is visible, you see the very dark part, this US part is there. So US, China, somewhere here in the Singapore, very small, that's not there. But these countries, US and China, they are consuming too much of energy while others are way too behind. So this data is of year 2016, but the bigger question is that if this kind of energy consumption is sustainable in long term, or how much more can be consumed to make people comfortable, because all this energy is going somewhere to make people life easier, right? So either they are being consumed in the building or they are consumed in the industrial for industrial output. So around 40% of the world energy is being 30–40% in these smart buildings, right? So is this kind of energy consumption is sustainable, and how much more can be consumed to make people comfortable? So once you compare it with the population of India, uh, we are very far behind in terms of energy consumption. So our footprint, carbon footprint, is also very less compared to the developed countries, which are consuming per person energy consumption is very high there. So per person energy consumption, I think in Singapore and USA would be at least 10 to 20 times of what we consume in India. So our global footprint are not that high. So here in this picture, if you see, it's a typical office building where you have the cubicles. So most of these developed countries, the offices are built something like this. You have a lot of cubicles, and you have the path to cross these cubicles. Okay? So individuals are sitting here, and if you see this picture, you will notice that different persons in the same room have different preferences, or they see the environment or they feel the environment differently. So if you see here, there is a person sitting here. He's complaining about the heat. So he's telling turn off the heat, means he's feeling cold, but just one cubicle away, this person is complaining about the heat again. That turn down the heat, means he is feeling warm, but he is feeling cold, and they are just one cubicle apart. This person here is complaining that I can't hear myself, means he's complaining about the noise in the office space. The person in this cubicle, just one cubicle apart, is complaining that there is no noise at all. It's too quiet in here. If you see the person in this cubicle saying it's really hard to type with your mittens on. So again, this the same problem. The person is feeling cold here. Again, the person is feeling cold there, and the person here is complaining that you could fly a kite in this breeze. Means he's telling that the air flow. So the air duct are installed in these buildings. So they bring in the fresh air, and he's feeling the breeze, that the breeze is too high, the airflow is too high, and he can fly the kite in this kind of wind which is inside the room. But the lady just decided that she thinks the otherwise. I don't think this air moved since 1957, means The person next is complaining that the breeze is too much. The lady feels that there is no air at all, and this person can smell the chili because uh, might be air purifiers are not there, or someone has eaten the lunch or dinner, or the airflow is not proper. He can smell few things. Here the person is, I think I can see my breath. So again, the person is complaining about the cold, and person here is complaining about the heat again. So this side another problem is there. This side the problem is there. Here another problem is there. They are all sitting in the same environment, same office space, and their perception about that office space is very different. Okay, so they perceive the environment very differently, and they all have different complaints. But we are not bothered about all their complaints. We can't solve all these problems. So we have taken up one problem in hand, and that is about this guy. So this guy here has a unique problem. His problem is that another day working in the dark, literally, he complains that the lighting is not enough. So his problem is the lighting. So might be some people feel that the lighting is too much. Some might feel that the lighting is not at all comfortable for them, or it's too low. And for some of them, it might be okay. So they are not complaining. So our task in hand is to make this person comfortable so that whenever he works, he neither gets a very bright light, he neither gets a very dim light. He should be able to control his lighting environment. That should be automatic also, or maybe the lighting should be fixed automatically based on his preferences. So whatever preferences he has been given, maybe last 1 month, 2 months, or 10 months, the system should automatically learn from his preferences, generate a proper lighting according to his day or timing. Maybe morning he wants to read the newspaper, the lighting should be set according to that. Afternoon he is having lunch, so he doesn't need a very bright light, the lighting should be set according to that. Afternoon he takes a nap for some time, so that the light should automatically dim a bit, and then in evening when he leaves the office, the lights should automatically turn off. So all this kind of smart lighting system, that's our target. So the target is to make this person comfortable and give him a solution for such a solution which is smart enough to cater his needs. So our target here, if you see, it's this figure shows the level of comfort of human being depending on the environmental condition. So if you see, most of the systems or the solutions are designed to meet around 80% acceptability. So in the market, if you see the solutions which are available nowadays, they feel or they are tested in such a way that if 80% of the people in the workplace are happy, then the system is considered good enough. But what about other 20%? So can we improve the system more, or we can increase the pleasure enrichment? So rather than just targeting the comfort of the user, a solution can also look for the pleasure enrichment, or we can go a bit higher in the pyramid and target the well-being of the building. So well-being of the building or well-being of the person can be improved by providing them the smart lighting system or a smart healthcare and productivity system. So ACMB part also comes there, pleasure enrichment, thermal and visual delight also comes there. So our target is to move somewhere here in the pyramid. So this picture here shows the typical office space, and this is the a typical NUS lab. So this was the lab in NUS, and here earlier they used to have the fluorescent light. Okay. So we have just replaced this fluorescent light with the uh, this LED lights. So if you replace this fluorescent light with the LED lights, straight away you can save 30 to 40% of energy. You will save the energy, but what about the person comfort? You are saving the energy, that's well and good. That will reduce the cost. The lighting would be better, but it not be good for all the people here. Some might have been adjusted based on those fluorescent light. They feel that those warm lights are better. But these lights, they are very bright. So for some of the people, those who are just sitting below these lights, they will feel the intensity. So these kind of system might not be very good, or might not be acceptable for all the people. So we need a system, or we want an intelligent solution, uh, so that we can minimize the energy usage as well as we can increase the user comfort. So how that can be done, that's the overall goal of this project. So considering the discussed issues of human comfort and well-being in indoor environment, we came forward with the following objective of the proposed work, and those objectives are listed here. So the first objective is to develop a smart lighting system, and that's the overall goal of this project. Then this system should take care of the heterogeneous lighting technologies and enable them for the intelligent function. So it should also contain a smart app. The hardware setup should be there. It should have some intelligence built in. So for that, a recommendation system is developed. Then you need to verify it. That is done based on the simulations. So before the lighting were installed, the simulations were done to correctly find out that which lighting should go where, how much intensity should be there, which side is dark, which side is bright, and how much it's needed, what is the area of the room. Based on that, lighting solutions were simulated. Then the system should also be having or taking care of the user comfort and well-being. And overall goal is to have the energy conservation. So we want to save energy, but we want to make a system which is making the people comfortable in their environment. So there are many other factors for the user comfort in indoor environments, such as the visual comfort, thermal comfort, IVQ, or the indoor air quality, what we call it. So, but however, in our proposed work, we are only targeting the visual comfort parameter of the user in indoor environment. So we need to remember it that these solutions were designed for the indoor environment. For the outdoor environment, there are different solutions which work. This is the layout of workshop 2 of NUS. So there are 6 floors, and in the 5th floor is the EMDL lab where these solutions were designed. So if you see this building itself is quite intelligent. So before the system were installed, installed, this building itself is quite intelligent. If you see that they already have the digital cameras, and these digital cameras to take care of the recording as well as the intrusion. To enter into the building as well as in any lab, just outside the lift, you have this card system. So security and access control has been taken care of. Fire alarms are there in each floor, and ACMB has been already installed. The wireless nodes are fixed for all the places, and different kind of nodes which has been governed centrally. Lighting control is there, smoke control is there, indoor air quality service is also there, power supply is there, energy meters are installed, and then other environmental control and all those systems are there. But the problem with this system is that all this is controlled by a central command system or central unit. So if you want to bring down your temperature, you need to call a person which is sitting somewhere, and you have to mention that I am calling from this lab, this room, and maybe it's too cold, so they will turn off the heat. Or you are not feeling good about your lighting part, you need to call them again, they will come and fix it, or maybe they do it remotely. But we wanted a system which you can control, or a person who is in that environment can control, and there should be no central command system kind of thing. So this building itself, WS2 Workshop 2 itself, is very intelligent. But we can go a bit further to make the people comfortable in these buildings. So that's why this solution we have bought. So what are actually the smart buildings, smart cities? Some of these points I have mentioned here, that smart buildings use information technology during operation to connect a variety of such systems, which typically operate independently, so that this system can share information to optimize total building performance. So the system in these buildings, they talk to each other. They have built-in mechanism, so that you collect the data, you use that data, you analyze that data, and come up with the solutions. So that information and analysis of building performance in terms of energy uses can be viewed by developing various type of wireless sensors to understand the ambient environment. And this system architecture that includes the smart sensor databases, the analysis part, and the visualization. So different type of information and reports are provided to administrator, building operators, guests, and local users. So it would help operators to plan or operate the building more efficiently, and end user can be aware of energy uses and change the behavior toward energy saving. So if a user can see that how much energy he or she is consuming, how much energy the person beside him is consuming, or how much is the total energy consumption of the building, how he can take part in that, then he might take action. Otherwise, somewhere the light is on, or his light is very bright, or somewhere the air conditioning is running, they don't care, because they don't have the information about it. They don't have the control of this. But if they have been given some kind of control or some kind of analysis, analyze data, some kind of analyzed data is given to them, the user, mostly the users are compelled to take action. They don't want to waste energy. Most of the users nowadays are very conscious about this environment, right? Environment saving and all. So they usually take action. So before we go forward, let's discuss about the proposed wireless sensor network framework of the smart lighting system. So we have three main components. First one is the personal agent, second is the local lighting agent, and third is the sensor nodes. So sensor nodes or sensor arrays are there. So these are the three main components of this system. So a personal agent is nothing but the user mobile phone or tablet or the system, where he or she can give the command, or he can control the system. Local lighting agent communicates with the personal agent through the Wi-Fi, and that is connected with the server. Okay, so server stores the user data for further processing, and local lighting agent communicates with these sensors using the Zigbee. Okay, so suppose different rooms are there. They say there is a big lab or big office where the room lights are there, conference room is there, meeting room is there, and maybe tens of meeting rooms are there where these kind of sensor arrays are installed. So these sensors continuously take the data, they take the environment, the reading, they give it back to the server. Local lighting agent communicates with the server, and then a personal agent can give the command, and the lighting can be controlled in these rooms. So these lights are not only operated by the personal agent, but they have a feedback system also. So you have personal agent, you have the lighting sensor, you have the lighting actuator where you are controlling these lights. So different communication mechanism are there. Zigbee is there, the Wi-Fi is there, your gateway is there, the server is storing the data. So every time the user is giving a preference, that is going to the server. So server is recording that data, and that data will be processed, and some intelligent algorithms have been developed. You can call it a recommendation based system, which later on can be used to intelligently control the lights. So suppose a person is there which comes to the office, and usually when you go to the office, straight away you don't start working. First, you might take up a book, or you might read the newspaper. So maybe for first few days, you keep the lux around 300 or 400 when you are reading the newspaper. But after 2-3 months, automatically your system can detect that every day morning 9 o'clock, you need 400 lux to read the newspaper. So automatically when you go sit on your chair, automatically your light brightness will increase. It will be 400 lux. Half an hour you read the newspaper, and then you put down the newspaper, and then automatically the light will detect that okay, your reading time is done. Sensor will detect that, and then you on your system. At that time, the lighting intensity would decrease or increase based on your earlier preferences. When you are going for lunch, system already knows that usually you go for lunch around 12:30 to 1:30. It will either switch off or make the intensity very low so that the energy consumption would be less. Once you come for after lunch, you usually take a nap for maybe 5 minutes or 10 minutes. So the system will detect that, it will go down, maybe switch off the light so that you can take a nap for 10-15 minutes. Then again it will brighten up so that you can start working. So we want an intelligent system, something like that. So this slide shows the lux requirement for various conditions of day of the working. So however, in reality, these are the inadequate smart lighting solution available in the market. So if you see the lux level for indoor car parking should be around 75. For corridor and rest area, this should be around 100. Stairs and escalator, this should be around 150. Lounges and canteen, it should be around 200. Background lights in office and classrooms should be around 300. In those conference room and meeting rooms are usually very bright, and there the lux level should be around 500. But usually that's not the case. You may feel like it's around 500, but if you go and measure it, it's around 350, 400. So these office, they want to save the energy, so they give you the illusion that okay, it's bright, but it's not actually bright in such a way that you can easily feel comfortable. So we need a system which automatically takes care of it. When you are in the conference room, automatically the brightness should be set as per the lux level. And for the quality control and precision lighting should be around 1000 lux. That is very, very bright. We don't need it for the normal day. So these are some of the components we have used in a smart lighting system to develop the hardware. First one is the PIR sensor that is used for detecting the presence of the human. Actually, we have used a heat sensor to detect the person. So PIR is the very basic one. Later on, I will be showing you the kind of PIR we have used. Then second is the illumination sensor for the feedback. It's the feedback sensor for the control of light lux intensity. Then digital to analog converter. Zigbee antennas are there for communication between the hardware and the server. Microcontroller used in this project is the Arduino Uno for handling data back from server and sensor values, controlling the light flux intensity. Then we have also worked on something very basic but very important part is the pinhole cover. So for limiting the illumination sensor view. And that part is also in our patent, and then the server PC. So for coordination between the personal agent and the local agent, the server PC is there. So if you see for PIR sensor, we have used the Panasonic infrared array sensor grid IO. So this is used to detect the presence of the user or the occupant. So this sensor is a high precision infrared array sensor based on the advanced MEMS technology. It detects the heat. It doesn't detect the movement of the person, which usually the PIR sensor does. So this technology is actually quite costly, but at that time when we have got that, one piece was around $40. Now it might be less, but for this kind of system where you need to install it, the cost is very high. But we believe that if we build the system in the mass scale or mass manufacture this, the cost can be bring down. And this is the illumination sensor. So it is a light to digital converter that transform light intensity to digital signal output. So each of these device that combines one broadband photodiode and it's visible plus infrared and one infrared responding photodiode on a single CMOS integrated circuit. Then if here our system is there, we have developed one pinhole design for the lux sensor. So we don't want the person to control the light of another person, right? So when this system is installed, it should be detecting the light intensity only in that person, maybe the table or the environment. So if this is installed in the above the cubicle of a person, it should be taking care of only that cubic. Okay, so only that cubicle should be taken care of. So the pinhole has been designed in such a way that it should fall only that. Suppose 3 x 3 meter area is there, only that much it should cover, not more than that. The personal agent is there, and that is nothing but the mobile phone or tablet. So this is the product which has been developed. This is the outer part, if you see. From here, the light intensity has been captured. This is the PIR sensor I have already shown, and inside that is the system. So here you can see the whole hardware, advanced hardware platform containing multiple sensors. So you have the light sensor here, you have the proximity sensor here, you have the Zigbee module here, you have Zigbee prototype board, Arduino custom Arduino shield is there, and this is the outer part, and this has been 3D printed. So we have printed a lot of this in mechanical department of the NUS. Then we brought it into our lab and then fixed our system inside that. So the component of the smart lighting system includes different parts. One of that part is the personal agent. So personal agent are the proxies for users in digital domain to modify the lighting requirement according to individual lighting needs. So this personal agent uh, software to call the app has been developed in our lab. So some of the BTech plus MSc students have developed it. So usually, actually, it has three modes. First one is the uh, manual mode, and in the manual mode, a user can manually adjust the brightness with the help of a slider. Second mode is the automatic mode, where the user can select this mode to automatically set brightness of room based on the present lighting condition. And intelligent algorithms also provide the recommendation in this automatic mode. So once you select automatic mode, you are actually giving the control to the system that it can select the lighting requirements for you. And the third one is the hybrid mode. So the user has a has more priority to override from automatic to manual mode. Then we have used certain communication technologies which enable the activation of lighting roads through a smartphone application. Actuation includes the on-off and dimming control. The smartphone application communicates with a program running on a remote server. And communication is established through TCP/IP within a Wi-Fi layer. These are some of the screenshots of the lighting, smart lighting app. So when a user opens the app, he is asked to enter the username and the password for authentication purpose. So only authorized person can access the light. So you don't want anyone else to access the light in your organization, right? So all the user first must be registered with the system. So once you register into the system, you need to enter your seat number. So why the seat number? Because we don't want any conflict. We don't want a person which is in the cubicle 1 should be controlling the light into the cubicle 30 or cubicle 40. So you should give when you register, you give your seat cubicle number that I am in cubicle number 1. You should be given the control of that cubicle lights only. So you don't want to people to fight over a light. So we have installed heat sink image processing sensor by Panasonic. So that sends the user in the perimeter, and if the user is not available, then the lights are turned off and reset to the minimum energy consumption. Okay. So once the authentication is done, a user will be directed to this page. So where he can choose one of the modes to control his lighting condition. So if he clicks the manual mode, he should be given this kind of now 5 controls, 5 buttons. Or there was also this other very preliminary picture I have kept. There is a sliding bar also. So from there he can control all the 5 different modes he will be taken given. If he chooses the automatic mode, the automatically the lighting condition will be set and the lux, ambient lux would be shown to him. Okay. So here automatically it has been set and lux value is shown to him. He can override it. He can choose it the hybrid mode. He can go back from the automatic mode to the sorry, automatic mode to the manual mode, and he can change it. Okay, so our system also includes the recommendation based system or the intelligent algorithm. So as we know that built environment often not tailored to meet the individual visual comfort needs, and to meet the need of personalized visual comfort with energy efficiency in office environment. We have also proposed a recommendation based system, and we have published this. Later on I will show you the publication. In case you want to know more about the recommendation based system developed for this, you can refer that paper. So I'm just skipping through it, uh, but just letting you know that these systems are advanced enough. They are not only controlled manually, but they have built-in intelligence. So the scheme user recommended system-based approach to learn both the individual and collaborative user preferences from historical data, and it offers recommendation for intelligent building lighting control. So intelligence is to generate light set point for personalized visual comfort with energy efficiency. So so this picture gives the idea about the working process of proposed recommendation based algorithm. Nothing much to see here. And this would be the environment where a person would be working after the successful implementation of the smart lighting system. So this is how a user desk would look like. Okay. So in offices, we always have this lights, fluorescent or the LED lights. We are going to treat them as the background light. We will set up a task light for each user, which he can control accordingly through his either desktop or mobile phone or the tablet. The sensor system is installed there. This part is for the ACMB that we are not talking about today. So these background lights, instead of keeping it 100% brightness or 100% illumination, we can dim it by 20%, 30%, 50%, or even 80%. So we can dim it and give control of this task light, so this user can control this and based on his requirement, he can manipulate this lighting. But this lighting he doesn't have the control. So the center authority has the control of this. So this is the floor plan of the EMDL lab, where the three routes have been chosen to implement this smart lighting system. So usually we give live demo, but only picture are possible here. So you can see when the system has been implemented. So task lights have been installed above the each cubicle. This actuator system node is there. It is detecting the light intensity here, and automatically it is giving the data back to the server. These background lights are there. These are the LED lights. Earlier, here where fluorescent light were there, we have replaced them with the LED lights. So each cubicle has this task light, and background light are as it is, and sensor nodes were installed. If you see here, there is one air purifier, and that is for the ACMB project. And due to time limitation, we are not taking up the ACMB part today. So, as in Singapore, during the daytime, we get enough sunlight. So we are harnessing the sunlight or using the energy harvesting to enhance the occupant visual comfort. So we are trying our different blinds for this purpose. So in case this is very bright outside, why to use very bright light inside, right? We can harness that lighting part. So But otherwise, most of the time it's raining also or very dark outside also. So in case it's very bright, the blind should open automatically and harness the light from outside. If it's dark outside, the blind should close automatically. So usually in office building, you see this kind of manual blinds. So we have tested three kind of blinds: motorized blind, manual blind, and voltage film. So the voltage film, if you give power to it, it can go opaque or transparent. Okay. So this film we have used. This is the motorized blind, which you can control using the remote control, and this can be controlled using the manually. Okay. So all these three systems have been used. The lux sensor you can see here. Outside we have kept the sensor outside also, just to check. And this system here, if you see, this was for the motorized blind. This figure shows the visualization of ACMB part. So the sensors are developed and placed in the lab. These sensors have the CO2 sensor, CO and humidity and lux level can be. So this was the lighting part. This kind of system were placed, and this part was the ACMB part. So the sensors are developed and placed in the lab. So this dashboard shows different readings. So it shows the humidity here, temperature here, illumination reading it is showing. Okay, and here the same data, humidity and lux level and carbon dioxide values are shown inside. So you will be surprised that inside these labs, the carbon dioxide level or CO2 level is around 5 to 6 times higher than the outside. So outside air is usually much cleaner than the inside, because so many students and people are sitting inside, and the ACMB systems are not that good. Before that, we were not aware of that. When we installed these systems, we found out that that is the case, and people were falling sick and all. So we have installed the duct to bring in the fresh air, and later on the environment become much better. In the same, if you see anywhere where the centralized air conditioning is there, same persists. So carbon dioxide level in these working places is very high. So that we have known after we have installed this system. This is not the part of this talk today. I'm just giving you the news. So actually we have covered all these components of smart lighting system. First was the server, which serves as the brain of the system to coordinate and store to make the decision. Sensors act as the eye of the system to detect the physical environment values. And then the controllers are there. They act as the hand of the system to control the output according to the set point received from the server by Zigbee. Then the lights are there, and these are the output devices to change the lux level, and personal devices. So these devices allow the human to system interface via the Wi-Fi. So let me conclude my presentation with these concluding remarks, that we have been able to develop a smart hardware platform containing multiple sensors, a smart app that controls heterogeneous lighting, enabling intelligent function has been also developed. Recommendation-based system for the intelligent approach to control the built environment has been developed. The system provides energy efficiency without compromising individual visual comfort. Uh, we have stimulated user engagement and behavior change toward energy conservation and sustainability. And in the ideal environment, up to 72% of energy reduction we have achieved in the lab. But how much it can be achieved when it would be installed in the real office space, that is need to be seen. And well-balanced indoor lighting conditions meeting individual user needs as well as the reduced energy consumption has been done. And in future, we will focus on maintaining individual occupant comfort in a building environment, considering other comfort parameters such as temperature, humidity, particle matter, and indoor air quality. So particle matter is basically for the outdoor environment. So these are the direct outcome of our research which has been done. So some of these papers have been published based on the work we have done. So this in energy procedure, one paper has been published. So this recommendation-based approach for personalized control, visual comfort, and energy efficiency in building has been published in Building and Environment and India. One conference in Vietnam, second in San Francisco, US. Then one conference in Singapore, one in the United States, and Japan, and one in the US. And at last 2019, when I have joined the NIT, at that time also we were building the system. So last paper has been published in 2019. That was in ICSET Bhubaneswar. So I thank you all for patiently listening to me and the presentation. In case you have any doubt, please let me know. And you can always message me or email me in case you remember something later on and you think that this is important and you want to discuss it. My mail ID would be there, and you can also reach out to me by phone in case anything is there. And I thank you all. Thank you.